Okay, hello everyone. My name is Daniel Troy. I'm a self-taught researcher and part-time experimenter, and I've spent the last 15 years trying to uncover and figure out a few things about the natural universe and about electricity. Now, what that has led me to discover is the principle of Tesla's operation, which is oscillating DC. It's not just normal DC, it's DC of a equal and opposite charge. The early electrical engineers and experimenters were using something they termed valence electricity, which was developed from piles of matter, zinc and lead plates and that type of thing, in two separate banks, one developing positive, one developing negative, sending off to a Leyden jar and discharging that into roads. And that's the type of thing that I've been trying to recreate. And to that end, I'll show you around the workshop. What I have is a small generator. Focus isn't very good at the moment for some reason. There we go. That's a blast generator, an old push-handled style blasting generator from a dynamite blasting machine. I've hooked it up to a 12-volt motor. This is a transformer, step-down transformer, that's generating a backup energy for the batteries. I've got two batteries down there feeding the 12-volt motor. They're hooked in series to develop 24 volts of energy, and I've got an ammeter here to measure the output. The energy from the generator. At the moment, I've got a little U voltmeter here, a 240, World War II voltmeter from the Japanese Army, hooked into the brushes of the generator. I'm going to show you that in a second, what the generator outputs. Across the brushes of the generator, I've got a bit dark down there. I've got a capacitor of value 330 picofarads, 200 volts. It's just there to stabilize the output. It doesn't actually increase or do anything else apart from clean up the trace, the signal. So that's hooked to there. From there, the energy out from the generator comes across to this little oscillator that I've got here. This is a Reed style oscillator out of a radio, out of an old 6-volt radio, portable radio. What these did was oscillated the battery energy into a transformer that then fired the valves. What I'm using it to do is to oscillate into a transformer and fire this globe. This globe's actually a headlight globe out of a car from which the filament has blown, the high beam filament. I've got it up against the white background so that you can see. Get across the post there. Once it focuses. Across that upper post, the wire is not connected. I don't know how clear that is. Anyway, so the output of the oscillator comes across these two. There's one here on this side, 270 picofarad, 250 watt volts capacitors. So one side of the oscillator comes to this one, the other side goes to the other one. They then go into this little transformer here, which is a TAM radio 4HJQT or TQT, 4HIQT maybe, I don't know. Then that comes up into this light, into this globe, and does some interesting things you'll see in a second. So what I'll do first is I'll turn on the the generator, and we'll have a look at the voltage from the generator without it being loaded up. And for some reason that's not working today. Oh, there we go. Just letting it sit flat. Oop. So we've got an output of 70 volts. It's on the 75 post. It's on the 75 volt post. Oh no, it's on the 150 volt post. So on the 150 volt post, yeah, 70 volts, which is the center scope. Whether it's readable. I wasn't watching the screen. It's not going to work because of the lighting. There we go. That's center volt, center mark there. I'll do it again. Up to 70. So the generator's outputting 70 volts. It's actually not DC. I'm not going to call it DC. Just unwrapping a lead there. I'm going to call it oscillating DC. It's pulsed DC. The scope trace for it I can do as well. Which is there. That's actually just blank. There's no signal going into it there. There we go. No signal going into it at the moment, but I can hook the oscilloscope up to the generator leads, and you'll see what the output of it is. So I've now hooked the leads from the that were going into the voltmeter up to the oscilloscope input. Let's see what we get from there. Set to DC coupling. It's right there, I don't know. Hang on a second. There we go. Let's see. That's the output from the generator. Directly into the oscilloscope. Now that trace is now down below the screen. I had to shift it up. Oh, shift it down. I had to shift it down once I powered it. So I'll have to try and bring that back up by. Let me remember this one. So it was way down there, 1, 2, 3, wherever the hell it went to, I don't know. So, as you can tell, I'm not very au fait with all this equipment. But what I can do is show you this. So we'll hook in the oscillator, and I'll turn it on. I better fire it up because it won't start itself. Oops, got a short. Hang on, I'm going to have to fix that. I'm going to have to fix that wiring there. It's not, I'm not going to play the game, I'm going to kill myself with ozone. Right, now let's see how we go. Now you can see there we go. You can see the discharge there, and then the ammeter. The plant meter here is across the output, and the plant meter is measuring occasionally amperage. Around 0.6, 0.4, 0.8, 0.5, 0.7. Well, amps, okay, watts there. And you can see the start. Now what I'm going to do is get this oscillator that is buzzing away. Buzzing away quite nicely there. I'm going to make that now by disconnecting and reconnecting this side. I'm going to make that do some magic. And there we go. Now the bulb is lit. No amperage is being recorded. And the oscillator, well, it's not very happy there at the moment. I can speed that, change that speed, but I'm not going to right now because it's a bit hard. But there we go. That's the type of discharge that Tesla was talking about, that needs a lot less energy to keep it going. As you can see, it's metering 0 amperage. Then it takes to keep it continuing.